Hi students, once again we are going to discuss some of the basic topics which we have been covering in our class, and today's topic is writing the electronic dot structures for molecules. So while writing the electronic dot structures, which are also called the Lewis dot structures, there are two things which we need to consider. One is the number of valence electrons. So the valence electrons are the electrons which are present in the outermost shell, the shell which is at the extreme distance from the nucleus, where the last electron adds up. So we are going to look into the number of valence electrons in an atom which constitutes that molecule. And the second thing which we are going to concentrate on is the octet. Now, what is an octet? An octet, as the name suggests, it comes from 8. So the tendency of the atoms in a molecule is to acquire an octet, means acquire 8 electrons in its outermost shell, and this comes from the noble gases. You know the noble gases has 8 electrons in its outermost shell, 2 in the S subshell and 6 in the P subshell. So most of the atoms in a molecule tries to complete their octet. That means they tries to have 8 electrons. Although there are exceptions to this rule, the atoms in the third or fourth or so period can extend their octet. That means they can have more than 8 electrons on it. Whereas there are one atom in the second period, boron, which has less than 8 electrons in its valence shell. So there are some exceptions, but most of the atoms, the majority of the atom, tries to obtain an octet while forming a bond with another atom in a molecule. So that's what we are going to learn today, writing the electronic dot structure. So for writing an electronic dot structure, what we need is we start with a symbol for an atom. Say, for example, if a molecule which is composed of carbon, then the symbol for the carbon is C. And if a molecule contains, say, for example, oxygen, then the symbol for oxygen is O. And if an atom has sodium in it, if a molecule has sodium in it, then the symbol for sodium is Na. So we should be familiar with these symbols, but we also have to take the help of the periodic table to find out the symbol for various atoms in a molecule. So once we have decided that, then we need to find out the number of valence electrons on a particular atom. Say, for example, here carbon. Carbon has 4 valence electrons, 4 electrons in the outermost shell. How do I know? There are 2 ways through which I can know. One is by writing the electronic configuration. So the electronic configuration for carbon is 1s2, 2s2, and 2p2. So 1, 2, and 2 here, they represents the shell. So this is the first shell, and these 2 here represents the second shell, the electrons in the second shell. So the first shell is nearest to the nucleus, and in this case, the outermost shell, which contains electron, is the second shell. So in carbon, the outermost shell is the second shell, and the valence electrons are the number of electrons present in the second shell for carbon. So how many electrons we are seeing here is, we are seeing 2 plus 2. So there are 4 valence electrons in carbon. So that's one way. The second way of knowing the number of valence electron is by looking at the periodic table. So in the periodic table, the elements in the periodic table have been categorized into groups and the periods. So if I know the group number, then I can very well know the number of valence electrons. So if I look at the periodic table, carbon belongs to the 4th group. So the group number gives you the number of valence electron. So carbon belongs to the 4th group, so that means it has 4 valence electrons. So either way, from the electronic configuration or from the group number. In the same way, I can find out the number of valence electron for oxygen. Oxygen belongs to the 6th group in the periodic table, so it has 6 valence electron. I can also determine by writing the electronic configuration for oxygen. The electronic configuration for oxygen is 1s2, 2s2, 2p4. And again, if you see in the second shell, which is the outermost shell for oxygen, there are 6 electrons. So that means oxygen has 6 valence electron. And when I see the electronic configuration of sodium, the electronic configuration of sodium is 1s2, 2s2, 2p6, and 3s1. So what it tells me, first shell, the second shell, and the third shell. So the outermost shell is the third shell. So how many electrons I'm seeing in the third shell? There's only 1 electron. So that means the number of valence electron for a sodium atom is 1. And I can also infer from it that the sodium will belong to the 1st group in the periodic table. And in fact, that's the case. So sodium is present in the 1st group in the periodic table. So I'll say the number of valence electron for sodium is 1. So that's how we determine the number of valence electron. So how do we represent, while writing the electronic dot structure, how do we represent the valence electron on an atom? We represent them in the form of a dot. That's the reason you have a dot in there. So there are 4 valence electron in carbon, and how do I represent it on it? Is by putting 4 dots on the 4 sides. Okay, so this is the electronic dot structure for a carbon atom. And how I can show an electronic dot structure for an oxygen atom is by having electron on 3 sides. But you can also, it doesn't make a difference, you can also show it 2 each on left and right and 1 each on above and below. So you can show it in that way, it doesn't matter in there. And in case of a sodium, since it contains only 1 valence electron, I'll show it just by 1 valence bond. Right? So this is just an atom. Now we know atoms are unstable, most of them, and they always look for another atom to combine to form a molecule. Now that's a molecule. When 2 or more than 2 atoms combine, and they combine in a way such that each of those atoms get stabilized. That's the reason the atoms combine, in order to get stabilized. So take for a very easy example here. Take for example the hydrogen. So how an hydrogen molecule is formed? An hydrogen molecule is formed when 2 hydrogen atoms combine, they form a hydrogen molecule. So how I can draw the electronic dot structure for a hydrogen molecule? It's very simple. Each of the hydrogen atom has 1 valence electron. The electronic configuration for hydrogen is 1s1. There is only 1 electron in the outermost shell. Hydrogen belongs to the 1st group, so only 1 electron. So the way a hydrogen molecule is formed is a covalent molecule when 1 electron on 1 hydrogen atom is shared by another electron on the other hydrogen atom. So the hydrogen molecule will look like this thing. So what it shows is that these two hydrogen atoms are sharing their electrons, and the electrons are present in between these two. So this is an electronic dot structure. But the structures, the molecules are not as simple as hydrogen. This is one of the simplest molecule. So as you look into the molecules, the complexity in the structure goes on increasing.